So the first thing I'm going to do is try to put as much of the information that I've got as possible onto my diagram. So the diagram shows a parallelogram. Okay, that's interesting to note. M is the midpoint of PS, so in fact this diagram really isn't drawn to scale. The distance PM and the distance MS should be the same, and it actually means that if PM is vector A, then so is MS, so I've labelled that on. If PQ is B, well, because it's a parallelogram, I can also draw these. So PS is A plus A, which is 2A, and so QR is also 2A. Those are equal vectors. So PS, we've just said PS is PM plus MS, which is A plus A, which is 2A. PR, so from there to there, well, we can do different routes. I'm going to go from PS and then S to R, so PR is PS plus SR, which is 2A plus B. The answer is 2A plus B. M to Q, going from M to Q, well, I'm going to go from M to P plus P to Q. M to P is the opposite direction but the same length to vector A, so that's minus A, and P to Q is B, so I've got minus A plus B, and you can either write the answer as minus A plus B, or perhaps it's a bit nicer to write it as B minus A. Don't forget to underline all of the vectors. For part B, I've put some more information onto the diagram, so it gives us that N is the point on MQ such that MN is a third of MQ. And then it says use a vector method to prove that PNR is a straight line. So this is pretty complicated. It helps to draw some things onto the diagram, and then we need to have a think about what's going on. Okay, so when I'm looking at this, there's several different ways to think about it. I think what I'm going to do is, if PNR is a straight line, then the vector PN must be a fraction, a constant, times PR, or vice versa, PR equals a number times by Pn, because they're going in the same direction, so they must be parallel, so one's a multiple, a scalar multiple of the other. So perhaps that's what I could try to aim to get to. So if I'm trying to get vectors Pn and PR, then the first thing I'm going to do to get Pn, I'm going to do Pn is PM plus Mn, so I need Mn. And Mn, we're told that the length Mn is a third times the length Mq. And in fact, that means the vector as well, vector Mn is a third of vector Mq. So using our result from part A, that's a third times B minus A. Okay, so Pn, this vector here, is the same as Pm plus Mn. Pm plus Mn. Pm we know is vector A, and Mn we know, we've just worked it out, a third times B minus A. If I expand out the brackets and add together, I've got A minus a third A, so A minus third A is 2/3 A, and then plus 1/3 B. So I've got 2/3 A plus 1/3 B, and in fact, just because I know it's going to be useful later, because I've done the rough workings, I'm going to factorise and say that is 1/3 times 2A plus B. So that's my vector Pn. So I next need to compare that with vector PR. So PR, we know from part 2, we know that PR equals 2A plus B. And now compare this, compare PR and Pn. They've both got 2A plus B, only Pn has got a factor of a third. So I can write that Pn is a third of PR. Or in fact, you could say PR is 3 times Pn. It doesn't matter, either one of these. We've now got the relationship where one vector is a scalar times by another, which means those vectors are parallel. So let's state that. So the key point is, if one vector is a multiple of another one, then those vectors are parallel. So Pn is parallel to PR. Okay? And that means, because I've got a P in both of them, that means therefore I can say PNR is a straight line. If I've got two vectors going out from P and they're parallel, then points N and R must be on the same line. So P, N and R must all be on the straight line, so PNR is a straight line. So this was a tough example. Remember, when you're doing these proofs, you might need to do a bit of rough working first. I did, on a little scrap of paper, I did a bit of rough working just to see if I could get everything. And then this solution is trying to show everything in order, building it up in logical steps, which is what you need to do for a proof.